Now we're going to begin Chapter 2. Our learning outcomes for this lecture are 2.1, describe an atom and how the atomic structure affects the interactions between atoms. 2.2, compare the ways in which atoms combine to form molecules and compounds. 2.3, use chemical notation to symbolize the chemical reactions and distinguish among the three major types of chemical reactions. 2.4, describe the crucial role of enzymes in metabolism. And 2.5, distinguish between organic and inorganic compounds. Matter is anything that takes up space and has mass. It's composed of elements. An example would be oxygen or sodium. And an atom is the smallest stable unit of matter. Atoms contain three major subatomic particles: protons, and they are represented by a P with a plus sign. They have mass and a positive electrical charge. They're found in the atom's nucleus. Neutrons, N, or N with a zero, they have mass and are electrically neutral. They're found in the atom's nucleus. And electrons are represented by an E with a negative sign. They have very little mass and have a negative electrical charge. They're found orbiting the nucleus at high speeds in an electron cloud or shell. This is an example of an atom. You can see the protons and neutrons in the nucleus of the atom and the electrons in the shell surrounding the atom. This is helium. There are some basic elements that are very important for the human body. The major elements of the human body are oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, potassium, sodium, chlorine, magnesium, sulfur, iron, and iodine. And their percent of the body weight is represented in this chart. The atomic number is the total number of protons in the nucleus of an atom. The total number of protons and neutrons in the nucleus of an atom make up the atomic mass. The atomic mass is not affected by gravity. Isotopes are atoms of an element with different numbers of neutrons in the nucleus. They're recognized by their mass number, the total protons and neutrons in the nucleus. Unstable isotopes are radioactive. Atomic weight is the average mass of an element's atoms, and it considers the influence of isotopes' differences in the mass. Atoms are electrically neutral. There is the same amount of protons as electrons. Electrons tend to orbit the nucleus in shells. Those in the outer shell can interact with other atoms. The number of electrons in the atom's outer shell determines the chemical properties of that element. Shells have a finite number of possible electrons. An atom with an outer shell that is filled is very stable or inert. An atom with an outer shell that is not filled will react with other atoms. Here's an example. Neon has 8 electrons in the outer shell, and it's very stable. It's considered an inert gas, where carbon has 4 electrons in the outer energy level and is more likely to look to bond in some way with another atom to gain stability. This is the checkpoint. Answer it. In chemical bonding, unstable atoms will react with each other by sharing, gaining, or losing electrons in chemical bonds. Molecules contain more than one atom bonded together by shared electrons. Compounds are made of 2 or more elements bonded together by any one of the kinds of chemical bonds. An ionic bond is a unique bond Some atoms will gain or lose electrons in the outer shell to gain stability. This will alter the atom's electrical charge. An atom that gains more electrons than it has protons will be negatively charged and is called an anion. An atom that loses more electrons than it has protons will be positive charged and it is called a cation. Make sure you know that. An ionic compound are formed by ionic bonds. Cations and anions are electrically attracted to one another. This is an example of a sodium atom with a chlorine atom. Sodium, in the second picture, gives up its electron to the chlorine. This makes the sodium positive and the chlorine negative. The opposites attract and they make sodium chloride a crystal, which we know as table salt. This is just the same image in a larger scale to show you what you're looking at. These are some anions and cations. Sodium, potassium, calcium, and magnesium are cations, whereas chlorine, bicarbonate, biphosphate, and sulfate are anions. Covalent bonds are the sharing of electrons between atoms. A single covalent bond, or the sharing of one pair of electrons. A double covalent bond is the sharing of two pairs of electrons. Covalent bonds are relatively stable and strong. Here are some examples of covalent bonding: dihydrogen, dioxygen, and carbon dioxide. There are different types of covalent bonds. Nonpolar covalent bonds is one type, and it's where the electrons are shared equally. A second type is called polar covalent bonds, and this is where there's an unequal sharing of electrons, and one element holds a shared electron more strongly than the other element. They form a polar molecule. Polar molecules have a slightly negative charge on one end of the molecule and a slightly positive charge on the other end. Hydrogen bonds are too weak to create molecules. They are also called weak hydrogen bonds. It's an attraction between a slightly positive charge on the hydrogen atom of the polar covalent bond and a slightly negative charge of the oxygen or nitrogen atom or of another polar covalent bond. An example of this is water, and we sometimes call it surface tension. Now, here's a checkpoint. Try to answer these. We did them in class. Now, there are three key types of chemical reactions: a decomposition reaction, a synthesis reaction, and an exchange reaction. Remember, the reactants are arranged to form products. Metabolism is the sum of all the chemical reactions in the body. Energy is the capacity to do work. There's two types. Kinetic energy is the energy of motion, and potential energy is stored energy. Energy can be converted from one form to another, and heat is a byproduct. This is a spotlight for us to go over chemical notation. The next images are just these in individual form. Here we have a hydrogen atom represented by H, an oxygen atom represented by the letter O. Two hydrogen atoms would be 2H, two oxygen atoms would be 2O. These are molecules. So we have dihydrogen, dioxygen, and water. So dihydrogen is represented by H2, dioxygen is represented by O2, and water is represented by H2O. This represents a balanced equation. 2H plus O makes H2O. The one underneath, 2H plus 2O equals H2O, is an unbalanced equation. It's very similar to algebra. Whatever you do to the right side of the equation, you must do to the left side of the equation. This is also a visual representation of sodium and chlorine and calcium. And we see that sodium ion is a Na+, chlorine chloride ion is Cl negative, and then calcium is Ca2 plus. Now, let's go over our chemical reactions. In a decomposition reaction, we have AB, and we break it down into A plus B. This is often called hydrolysis or catabolism. What they do is they split the water and add it to the A and B. Decomposition reactions in the body release kinetic energy for work. Synthesis reactions make larger molecules from smaller parts. We have A plus B and we get AB. It's called dehydration synthesis. Water is removed and the two parts are put together. Finally, in an exchange reaction, it's a shuffling of parts and molecules. We have AB plus CD, and now we get AD plus CB. A decomposition reaction is followed by a synthesis reaction. Are chemical reactions able to be reversed? Yes, they are. This is symbolized by the two arrows going in the opposite directions. When a chemical reaction is at equilibrium, the rates of the two reactions are in balance. Here is the next checkpoint. See if you can do this. Now, let's talk about enzymes. Enzymes aid in chemical reactions. They lower the activation energy, that's the amount of energy required to start a reaction. They also act as catalysts. They speed up the rate of chemical reactions. They are not changed by the reactions. This is an image showing this. You can see how much less energy is required to make the chemical reaction go with an enzyme. There are a couple types of reactions called exergonic reactions and endergonic reactions. In exergonic reactions, the release of net energy is because it took less to activate the reaction than was released. In endergonic reactions, they absorb net energy because it took more energy to activate the reaction. Most reactions in the body are exergonic. And this is to keep us warm because we generate heat as a byproduct of these reactions. We finish up with organic and inorganic compounds. Nutrients are essential elements and molecules obtained from the diet. Metabolites are chemicals that come from catabolism and anabolism in our bodies. Organic compounds are small and usually without carbon and hydrogen together. They may have carbon dioxide, but they don't have carbon with hydrogen together. Water, for example, is inorganic. It doesn't have carbon and hydrogen together. Organic compounds are large, complex, and usually are made of carbon and hydrogen together.